So let me do that one because that's a little different. Again, you already have your mass, so that's 90 divided by 300. You just do that in calculator, 90 divided by 300, which would give you 0.3. So 0.3 seconds. And then 13 would be this pretty similar to one up here. 40 inches, which exposure receive at 72 inches. So you'd work it out just like this one. So we'll work this one out as well. So your intensity, again, the formula, I had to flip pages. Yep, here's your formula. Direct square law, or sorry, KVP. I know what the law is. Hold on, let me look at that before I tell you the wrong answer. Oh, excuse me. You would use 13. Inverse square law. Okay, super easy because it's milliroentgens. Oh yeah, this is sorry, that is not like this one. This is direct square law. This is inverse square law. Sorry, because you're in inches, you're milliroentgens. That's your KVP. That's KVP law. That's different. So regarding what I just showed you, this is inverse square law. So I1 over I2 equals distance 2 over distance 1. Square. Sorry, I get confused too. So this is the formula you're using. You just plug the numbers in. So 120 equals your distance. Your second distance is 72. 72 squared. First distance is 40. 40 squared. So just square those off. 5186 over 1600 equals 120x. Cross multiply 120 times 1600, which gives us 192,000 equals 5186x. Divide this number from that, so 192,000 divided by 5186. 5186, which gives us a beautiful number of 37.02, and your units are in milliroentgens. 37.02 milliroentgens. You do the same for this one. So the main difference between inverse square law and direct square law is you see how this one has KVP, this one has distance. This will be your indirect square law, and the one with the mass, so in question 5, will be your, what did I say? Question 5 would be your KVP formula. So they do look similar, but look for the inches in KVP. KVP formula, that is directly proportional. Inverse square law, as the name suggests, inverse. So your things are inversed. So yeah, the next question here, what's your mass? Would you need? So this is direct. So your mass, so mass 1 equals D1 over mass 2 equals D2. There are too many dang formulas in this freaking packet. Yeah. Inverse square law, direct square law, KVP formula. Whew, I'm sorry. That is a lot, even for me. So as the name suggests, direct square law, directly proportional, mass 1, distance 1, mass 2, distance 2. Plug the numbers in. So 80 mass over your distance 1 is 40, distance 2 is 72. You square those. 1600 over 5186 equals 80 over x. 1600x equals whatever this is multiplied, so 5186 times 80, 414880 divided by 1600 equals 259.3. So 259.2 mass. Again, units. 259.3 mass. So yeah, direct, indirect, and again this is indirect because you're milliroentgens and you're in distance. So that's just like this one. And again, just you gotta really read these problems because they will kill you, and they screwed me up already. So indirect square law, 120 milliroentgens at 40 inches. That's the big thing you want to look for. Milliroentgens, your distance. Your direct is your 80 mass at 40 inches. There will be no mention of kVp. Now, he could throw in kVp in these things just to screw with you. But if you're used at 80 mass at 40 inch SID, what would your new mass need? So you want to look at the end of the question and see what would the mass be. That would be your direct square law. If you're looking for the exposure, that would be inverse square law. Come back up here. What will your exposure be? So, and you have kVp milliroentgens. What is the difference? Hold on, I'm sorry. Yeah. And you want your exposure, but you have kVps. That's your kVp formula. That is a lot, I know. So, one more time. If your exposure to a patient 25 milliroentgens at 60 kVp, what will their exposure be at 70 kVp? So you're looking for your kVp. So your exposure with kVps would be your kVp formula. But if you come down to 13, your patient received 120 milliroentgens at 40 inches. What would your exposure be with the patient at a new SID distance? So distance, exposures, you gotta really read those questions at the end. What are they looking for? Because he could throw in on this here, he could throw in mass and throw you all off. So definitely read what they're looking for and what numbers you need and which ones you don't need. Again, get these formulas ingrained in your head. I know that was confusing in the last like 2 minutes I just explained. That's another question. 16, 175 mass, 40 SID. What mass would you set for X-ray? So that would be your direct square law because you're looking for your mass at distance. If you have any questions about this, definitely let me know when we do call later, and I'll explain that a little better for y'all. But yeah, I'll end this video because this one's pretty long as well. 17 minutes, yeah.